Hello and welcome back to P Academy. So this is a continuation to the question you're currently seeing on your screen. In the previous part of this video, we've solved the A part of it, which is this one. We've solved it already. And if you missed that part, you might just check the playlist on Signals and System. You'll find it. So these are just the solutions. So we've done. So now in this particular one, we want to look at the B part. Alright, so before we get into it, if you are new to this channel or you are yet to still subscribe, please just take out time, click on that subscribe button below the video. It's absolutely free. Please just take a few seconds to click on that subscribe button. Alright, so thank you very much if you have just done that, and now let's get into it. So the second question is how to answer questions under signals and systems if you are asked to find the amplitude spectrum, the phase spectrum, and the power spectrum. So if you look at the question, you see that it's a continuation to the A part. It says, assuming the sampling frequency is 100 Hz, compute the following from the sequence given in A. So that means after we must have answered the A part, which we've done in the previous video, then we can go ahead to answer the B part. So what I want to do now is, let me give you the formulas that we are going to need to solve the B part. So we are asked to find the amplitude spectrum, the phase spectrum, and the power spectrum. So now let's get started. So let me start with the first one, amplitude spectrum. So for amplitude spectrum, so the formula is giving us K multiplied by Fs. So that Fs is what we have as the sampling frequency over N. So this is the capital N that we use when solving the first one, the A part. So the next one is the phase spectrum. So for that, the formula is 1 over N multiplied by positive value of x of k. And we can also rewrite this as 1 over N. So let me just write this properly again. So 1 over N multiplied by the square root of the real value of x of k x of k square plus the imaginary, that's imaginary of x of k, the imaginary part of x of k, that's not showing well, f of k all square. So I hope you can see it. The imaginary part of x of k all square. Okay, so don't worry, we are going to see the application of all of these formulas and then you're going to understand better. So to get the phase, or you can call it theta, so that's equals to tan inverse of the imaginary part of x of k over the real part of x of k. Okay, so now for the third one, so which is the power spectrum. So for that, we have it as 1 over N square so multiply by x of k square. So that's the positive value of x of k, and then we are going to square it. And don't forget this x of k. So let me just change the color. So this x of k, to get the value of this x of k, we'll just apply this. Exactly so. Or let me just rewrite it. So you can also rewrite it as 1 over n square multiplied by so that's the square root of the real part of x of k all square plus the imaginary of x of k all square. So square, and then that's the positive value. Let's add this. Now you might be thinking that this square should just cancel this square root, but no, don't do it like that just yet. And then you're going to know why when we start to solve example. So these are the three formulas we are going to be using to calculate the amplitude spectrum, the phase spectrum, the amplitude spectrum, the phase spectrum, and the power spectrum. So now let's apply it. So from the question again, let's go back. It says, assuming the sampling frequency is 100 Hz, so that sampling frequency is our f of, so let me just write solution. So that means our fs is equals to 1000 Hz. And then from the question A part where we solved in the previous video, we already know that our capital N is 4. I've explained that. Then what other information? And then we have already established also in the A part when we solved it that our k, the value of our k is 0, 1, 2, and then 3. Okay, so what other information do we need? So we'll pick other information as we progress. Alright, so now let's start with calculating the amplitude spectrum. So what we are going to do is we are going to calculate the amplitude spectrum, the phase spectrum, and the power spectrum when k is 0, 1, 2, and 3. Exactly. So now let's start. So I'll say when k is equals to 0. So when k is equals to 0, now let's calculate the amplitude spectrum. So when k is equals to 0, amplitude spectrum so the formula is given as k multiplied by fs over n. So that means we're going to be having our k is 0, so that will be 0 times 1000 divided by 4. So and that will just give us 0. So exactly. So let's go to the next one. So for our phase spectrum, so for the phase spectrum, so we have it as 1 over n. So the formula is here already. So this is it. So let's just input the value. So that's 1 over n multiplied by, let me just write the second side of it. So let's work with this. So that's 1 over n times the square root of the real. So the real part of x of, so that will be x of 0 now. Remember it is x of k. Or let's just write the formula itself. The real part of x of k plus the imaginary part of x of k. So now let's put in the values. So that will be 1 over 4 times the square root of, so the of the real part. So I don't want to skip any steps so that you won't get lost in any part of x of k. Other x of 0. Remember now we are dealing with when k is 0. You can see it here when k is 0 plus the imaginary part of x of 0. So that would be 1 over 4 times square root of. Now let's go to the a part when we solve the a part of this question when k is equals to 0. So let's go back to that question. So you can see it. So when k was 0, we got our answer to be 10. And since the answer is just 10, that means our real is 10 and our imaginary is 0. Exactly. Alright. So that means our real is 10. Okay. I think I missed something in this formula. I missed the square. So there will be a square here. There's a square here. So we are going to be having 10 square plus 0 square. Okay, so I don't want to miss any step. That's why I'm just taking it like this. So that will be 1 over 4 times square root of 10 times 10, that is 100 of 100. So it will still give us 1 over 4 times 10. Is that square root of 100 is 10. So that will be 10 over 4. And then this would give us 2.5. 2.5. Are we good? So now let's calculate the angle there. So for that, we have it to be tan inverse of the imaginary part of x of k over real part of x of k. Okay, so that will be the tan inverse of the imaginary. So this IMAG is an abbreviation for imaginary of x of k over the real of x of k. And that is saying tan inverse of the imaginary part of x of 0 over the real of x of 0. Alright, so let's put in the value. So that will be tan inverse of, so the imaginary of x of 0 is 0, and then while the real part is 10 over 10. So 0 over 10 is actually 0. So with that, if you have to calculate the angle, so that means you're going to be having tan inverse of 0, and that's going to give us 0 degree. So that is for the phase spectrum. Now we've done all the calculation that has to do with the phase spectrum. So now let's move to the power spectrum. So for power spectrum, so if you are finding value in this, please click on that thumbs up button to give the video a like. Alright, so for the power spectrum also, let's write out the formula again. So this is 1 over n square multiplied by the possible value of x of k all square. Alright, so just give it, we can write it this as 1 over 4 square multiplied by, since we are still dealing with k is equals to 0, 0, let me write that back right, all square. So this will be 1 over 16 multiplied by, now what we are having here, the difference between this, okay, let me go back to that formula again. Alright, so this that we are having here for the power spectrum is the square of this value here. Exactly. So that means whatever we get when calculating the phase spectrum, whatever our x of k is, once we want to apply it to the power spectrum, we just square it. Exactly. So that will save us some time. So now let's go back to our x of k. So when we're calculating our phase spectrum, we got our x of k. When k is 0, we've got it to be 10. Exactly. So we can just bring it here to be 10 square, and that's equals to 1 over 16 times 100. So that's 100 over 16, and that will give us 6.25. So if you're in doubt, you can just do the calculations, and then you see that you're still going to get the same thing. So that is, if you want to, because I'm going to back to the formula now. So if you just want to, instead of writing out all of this again, exactly, instead of going through all of this again, that's just to make the work much more easier. So with that, now we've been able to get the amplitude, the phase spectrum, and the power spectrum when k is equals to 0. So what we are going to do next is we are going to repeat the process again and say when k is equals to 1. Exactly. So we are going to go through all of this again. So what I will just do is, again, I will just do it when k is 1, and then I will leave the rest for you so that you can try it from your hand. So that you can try it from your hand when k is 2 and when k is 3. Exactly. So once you do that, let me see your answer in the comment section. So now let's do it again. So in case you are not, you didn't get or you are confused with this first one where we did when k was 0. So pay attention again to this. We are going through it again. It's just the same step, but just that the values will be different. So now that k is 1, so now let's start again. So let's calculate when k is 1, let's calculate the amplitude. So again, I might not write out the formulas again. Exactly. So the amplitude is, the formula for the amplitude is k multiplied by fs over n. So that will give us, so now our k is 1, that will be 1 times 1000. Don't forget this 1000 hertz was given in the question already. Then our n is 4. So from the question also, I've explained that in the previous video. So that will be 1000 divided by 4, and that will give us 250 hertz. Exactly. All right. So that's it for that. So let's go to the next one. So for the number 2, let's calculate the phase spectrum when k is 1. All right. So for the phase spectrum, so the formula is 1 over n multiplied by, so the square root of the real part of x of 1. So I won't be writing x of k again to save us time, plus the imaginary part of x of 1 all square, x of 1 square. Okay, so that will be 1 over 4 times, so the real part of x of 1, let's go and pick what the real part and imaginary part of x of 1 is, and we'll get that from the A part of the question, and that's the one we solved in the previous video. But let's go there and check what the real and the imaginary values are for x of 1. That means when k is equals to 1. So let's see. So this is it here. When k was equals to 1, so you can see when k is equals to 1, we got our answer to be 2 minus 2j. So that means this 2 that we are having here is the real part, while this minus 2 is the imaginary part. So let's bring it in. So that means the real part here is 2. So we are going to be having 2 raised to power 2 plus, then the imaginary part is minus 2. So let's just have it as minus 2 square. So that will give us 1 over 4 multiplied by square root of 2 square is 4 plus minus 2 square is also 4. Exactly. So let me just continue here. So that will give us 1 over 4 multiplied by, now 4 plus 4 is 8, square root of 8. That should give us, let's see, square root of 8. That will give us 2.8284. So that will be 2.8284 divided by 4. So So that will give us 0.707. Are we good? So that's how you go ahead with the calculation. Now let's just calculate the angle or the phase. So don't forget, for that is going to be tan inverse. So tan inverse of the imaginary part of x of 1. So let me just go ahead and write it straight. X of 1 divided by the real part of x of 1. Okay, so now let's continue. So that will give us tan inverse of, now the imaginary part is -2, right? So that will be -2 over the real part of x of 1 is 2 over 2. Okay, so let me just continue here. So this will cancel this, so we are left with tan inverse of -1. And if you check your calculator to look for the value of the tan inverse of -1, that should give us -45 degrees. But let's just confirm. So tan inverse of -1, you can see, so that's -45. So that's -45 degrees, and that's the answer for the phase spectrum. All the calculation that has to do with phase spectrum, we've just done it. So now let's look for the power spectrum now. So for the power spectrum, okay, so let me write the formula again. 1 over n square multiplied by, so x of k square. So that would be 1 over 4 square multiplied by, so for this x of k, we don't really need to do any calculation. We can pick it from here. So this will be the value for x of k. The only thing we need to do now is to square it. Exactly. All right, so that's 2.8284. So multiply by 2.8284 square. So that will be 1 over 16 times. So let me square 2.8284 square. That will give us 5.2093. Okay, so that will be, so 5.2093 divided by 16, and then let's see. So that will give us 0.3255. All right, so we've done the calculation when k is equals to 0, when k is equals to 1. So like I said, so you go ahead and calculate the amplitude, the phase spectrum, and power spectrum when k is equals to 2, and then when k is equals to 3. So, and then let me know what your answer is in the comment section below. So I believe you've gotten the concept on how to calculate amplitude, phase spectrum, and power spectrum when you are dealing with questions relating to DFT or signals and system. So I hope you find value in this. If you do, please give the video a thumbs up. And in the next part of this video, you are going to be looking at the C part. You are going to be solving the question C of this question that you are seeing right now. So we are going to be doing this in another video, so which is the next one. All right, so thank you very much, and then I'll see you all in the C part of this question.